what we did yesterday is you guys can see this is an identity. Basically what they're saying is the left side is equivalent to the right side, right? And can we have sides equal to each other that don't look exactly the same? Can we have 3 plus 4 is equal to 7? Right? They don't look the same, but they're equivalent, right? You guys agree? So that's an identity. This is, this is an identity. So what we're going to, what we need to do is verify the identity. Verify that one side is equal to the other side. So what you guys can do is you can just kind of create a nice little dotted line on any problem that you guys are doing. And I'll leave this one up here, so you guys don't need to write it down if you don't want to. So what we're going to do is we're going to kind of create a line, because basically the reason why I create that line is if we're not solving equations. We're not subtracting something on one side to the other side. We're only going to work on one side at a time. And the side that you want to work on, that you want to choose to work on, is the one that's kind of the most complicated, or the one that has to multiply, the one you have to add or subtract, the one that has the most trigonometric functions on. So if you guys look at these two, right, you could say, well, you could try to combine these two together, or you could also multiply this. Well, I would probably say that this would be the one that I want to simplify, because it'd be much easier for me to expand this and to show that it's an addition rather than to try to combine this and make it look like that, right? Wouldn't you guys kind of agree? It'd be easier to factor this out. So remember, cotangent theta plus 1 squared is cotangent of theta plus 1 times cotangent of theta plus 1. Just like in algebra, we have to apply FOIL. You could use the FOIL box if you'd like to. But when I multiply this out, I get cotangent squared of theta plus cotangent of theta plus cotangent of theta plus 1. Right? And then these two terms are like terms. So I have cotangent squared of theta plus 2 cotangent of theta plus 1. Now again, we want this side to look like that side, right? We want this side to look like that side. So the problem is we have this cosecant. We have this cosecant here. So how am I going to change this to cosecant? Well, again, it's a cosecant squared, right? So let's look back at our identities. What is cosecant, Haley, what is cosecant in our Pythagorean identity?
1 over sine.
Okay, but the cosecant squared.
Oh.
Pythagorean identity. What is it? I didn't hear you. What is it? I want you to say.
1 plus cosine.
1 plus what?
Cotangent.
1 plus cotangent squared of theta equals cosecant squared? Okay, so that's your Pythagorean identity. That's been given to you. We can rewrite this. I can change this around. So could I maybe subtract 1 on both sides and say cotangent squared of theta is equal to cosecant squared of theta minus 1? Would you guys agree with that? So since I know cotangent is equal to that, why don't I replace this cotangent so then I'll have a cosecant? So I'll do cosecant squared of theta minus 1. And then plus 2 cotangent theta plus 1. And now what happens is the 1's add to 0, and I'm left with this. Do you guys now see how the left side is exactly the same as the right side? Yes? So, and I forgot to mention, every single time you guys are doing this, you're going to want to include equal signs, because it still equals to the right side. I forgot to do that. I got lazy. I'm sorry. And then you can just show me that it's checked, verified at the side. OK? Yes? You could have, yes. Yes. You could have just said 1 plus cotangent. I have a 1 and I have a cotangent, and replaced it. Yes. I just did that for kind of instructional purposes. But yes, you could have just obviously seen that, hey, there's a 1 there and a cotangent. I can just throw in a cosecant. Yep, absolutely. Any other questions on that? No? OK. All right, guys, there's nothing like learning like